So, just so you know, chapter 4 and chapter 5 kind of are two parts of the same whole. So, there are going to be some things that we talk about in this chapter that we're going to talk about in more depth and detail in the next chapter. So, just kind of pretend like 4 and 5 are just one big chapter. We're talking about some things that are big issues in research. So we've kind of talked around these things before. We've talked about pseudoscience and how to determine causation, but really looking in depth at these things helps you understand how different issues can come about while doing research. Understanding these issues allows you to analyze other research and see potential flaws, and also look at your own research to make sure your study is designed as well as possible. So, one of the most important topics that we'll cover is the idea of validity. Validity asks the question, are you measuring what you want to measure? So think about this, right? If you're using some sort of measurement tool, the assumption is that whatever you are measuring or whatever you think you're measuring, you are actually measuring, right? Think about stepping onto a scale. What does a scale measure? You probably said your weight. That is partially correct, right? So, one, it also measures how long it's been since you've eaten or eliminated. Eliminating is a very fancy scientific word for pooping. So, if your stomach and bowels are empty or full, that is going to affect your weight. What clothing you're wearing, right? The time of day is going to affect your weight. Water retention, right? The temperature. Also, where you are geographically. So, depending on how close you are to sea level, your weight is going to be affected. And also, just in case you're doing some interplanetary travel, right? If you are in space, then your weight might be nothing. You could be weightless, right? So, a scale, we assume, measures only weight, but it measures more than that. Also, sometimes we use weight as a measure of healthiness, right? So we say that if somebody is overweight, then that means that they're less likely to be healthy. But is it possible to be weight that's higher than average, but still be healthy? Also, is it possible to be underweight and be unhealthy? The answer is yes, right? You can be very muscular and have a lot of musculature, which would mean that you're more likely to be heavier because muscle weighs more than fat. So if you're only looking at your weight as a measure of health, then you're going to maybe feel that you're not healthy. It's not necessarily a valid measure. Or if you're the type of person who just is trying to get that number as low as possible, and you're like, well, I need to get my weight down more and more so I can be healthier. Well, that's not necessarily a good thing. Sometimes your weight is low because you're malnourished, right? So we think we're measuring health, but we're just measuring weight. And there are other aspects to health that are important, right? So and if you imagine this, let's say I'm trying to see whether a certain behavior or a certain drug affects your well-being, right? And I'm trying to see if people are healthier, but it's only a weight loss drug. I might say, look, it makes people healthier, but it's actually just making people lose weight, right? So if I don't have valid measurements, then my study starts to fall apart, right? So there are multiple types of validity. We're going to talk about three right now. One is called construct validity. A construct is simply a any idea, right? So if you think about something like justice or love or attractiveness, right? Or talent. So all these things are words and ideas that we kind of as a society have like agreed have a specific meaning, but like they're just kind of things that we make up. They don't actually exist in the world. You can't point to justice. You can't hold love. You can hold someone that you love, but you cannot hold love, right? And what love looks like is going to depend, right? What looks like loving romantic behavior to one person might seem like toxic, clingy behavior to another person. So when we're talking about construct validity, we want to make sure that we define our variable well enough so that we're measuring what we're trying to measure. Then we have internal validity. So internal validity is the idea of, can we properly determine cause and effect? If we are studying something, right? We're looking at a relationship between two variables. De- have we designed our study well enough so that we can properly determine the relationship between variables? So have we defined our variables well? Have we reduced the potential effect of third variables, right? Uh, the uh, the a well-designed study is going to have high internal validity, meaning that when we find out what that relationship is between those variables, we're pretty sure that it's because that actually is what it is and not because there's some other thing that we didn't account for, right? So let's say I was trying to do a test to see if providing a study guide actually helps students do well, right? So I give half of my class a study guide, half of the class does not get a study guide, right? Now, what I did not realize is that the study guide that I gave people was actually the key to the exam, right? Oopsie, I sent the wrong email attachment. So everyone who got the quote unquote study guide just got all the answers to the exam. So when they took the exam, they just went, well, I already know all the answers, right? Everyone without the study guide did okay, but not as well as the people with the quote unquote study guide. This has low internal validity because I'm not giving people a study guide, right? It's not a well-defined variable. It's not a study guide. It's just the answers. That's not what a study guide is. So, I mean, some professors might do that, but in my opinion, that's not what a study guide is. It's a guide for studying, not an answer key. But that's an issue of like a construct, right? What is a study guide? So I can't say that a study guide actually is helpful in that case because the study wasn't designed well enough to account for that. There was a flaw in the study. Anytime there's a flaw in the design of a study, you have low internal validity. Then we have external validity. External validity looks at whether or not the results of your study apply to people outside of your study. So a great example of external validity are these like political surveys about like who people think who people think is going to win an election. So for example, 4 years ago, or if you're listening to this in the future, in the year 2016, there were a lot of polls saying that Hillary Clinton would win and become the next president. Now, that's an issue with external validity, right? It could have been a well-designed survey, right? According to the survey, that many people believe that were planning on voting or believe that Hillary would become the next president, right? But that didn't represent what actually happened in the real world, right? Or for example, hydroxychloroquine, right? So there are some studies that showed that the drug was an effective treatment, right? There are also a lot of studies that showed that it didn't, but that is an example of external validity, right? Just because some people in the study felt better doesn't necessarily mean that everybody outside of the study will feel better. We have to be very careful about taking information from a study and just automatically assuming that we'll find the same results outside of the study. So that's external validity. Can the results inside of the study apply to people outside of the study? So let's talk a little bit more about construct validity. So you should be familiar with the term operational definition. The operational definition is the specific definition of a variable used in a study. So let's say we're talking about aggression. I might define aggression as only physical aggression, right? Hitting, pushing, being like an intimidating presence, right? Stuff involving the body, but not verbal or relational aggression. Or I might choose to measure all types of aggression, right? If one study, and understanding the operational definition is important because one study might say aggression and they might be just referring to physical aggression, but another might refer to aggression and they might be referring to verbal, physical, and relational aggression, right? So it's important to understand what operational definition is being used because that affects the construct. Aggression could mean a lot of things to many people. So you have to be specific in your study about what operational definition that you're using. So in a study, we're measuring this relationship between the independent variable and we assume it affects this dependent variable, right? So we have our independent variable and we're assuming it affects the dependent variable. We're hoping that there aren't any third variables that are affecting this relationship. When we are aware of what these third variables are, we call them confounding variables. But what we try to do is we try to control for them, right? And we can control for those third variables by making sure that we have a clear operational definition. If we're only studying relational aggressions like being passive aggressive, leaving people out of groups, those types of things, right? Then we want to make sure that our operational definition doesn't include physical aggression. That's going to make sure that we don't measure things that are unrelated to the thing that we're trying to measure. So really having a good operational definition is one way to increase the overall validity of your study. So internal validity is, again, dealing with the ability to determine causation or a relationship between the variables in your study, right? You might be wondering why there are controllers in the background. Well, in a study, what you do is you have control over usually the independent variable. But the more control you have in a study, the more the more internal validity that you have, right? So let's say I'm doing a laboratory experiment and I'm doing a drug trial. I tell all the participants in the study how much of the drug they receive, right? Maybe they get a placebo pill, maybe they get 10 milligrams, maybe they get 20 milligrams, right? So the because there's so much control, it makes it less likely that third variables are going to interfere with the study, right? So the more control you have, the more internal validity that you have. So highly controlled studies are usually referred to as laboratory experiments because you're telling everybody what they're going to do. If it's like a sleep study, you're like, okay, this is when you sleep, this is when you take this thing, right? The more control you have, the more you can eliminate the effect of third variables. But because the real world isn't so controlled and so sterile, right? you have less external validity because what's happening in the study doesn't reflect what's happening in the real world. So sometimes increasing your internal validity can affect your external validity. On the other hand, the more similar your study is to the real world, the more likely you're going to have very high external validity. So if I am doing a study and I invite couples to come to my office and have an argument, right? It's not going to have the same level of external validity as if I were in their home watching them have an argument, right? Because being somewhere that you normally are not, you're going to behave differently. That's just social psychology. We behave differently based off of the context, right? So if I'm able to be out in the field, that's why I chose this photo. It's a field, get it? So they're called field experiments. If you can go out to where things are actually happening and leave things as undisturbed as possible, you have high external validity. You have high external validity because the surroundings of the study reflect what's actually in the real world because you are in the real world. But because you are in the real world, what's going to happen? There are going to be other third variables that you cannot control for, right? You give up some of that control to have higher external validity. So often when you have higher external validity, you're losing some of that internal validity. So last thing, we want to talk about the relationships between variables. Okay, so when looking at two variables, one of a few things can happen. So let's say I'm looking at drinking and intoxication, right? The more that I drink, what happens to my level of drunkenness? If I drink more, I get more drunk. That is referred to as a positive relationship, right? As drinking increases, my intoxication also increases. That's a positive relationship. Now, let's say I'm looking at drinking and my ability to drive. The more I drink, what happens to my ability to drive, right? As my drinking increases, my ability to drive decreases. That is a negative relationship, right? So the as one thing increases, another thing decreases. That's negative. Now, let's say I'm looking at my how much I'm drinking and how many children I have. Uh, you might say that there's a relationship there, but let's just pretend like we're just measuring it like over the next week, right? So I drink and I drink and I drink and I drink, right? And some days I'm drinking a lot, sometimes I'm not drinking a lot. But weirdly enough, the number of children that I have does not increase or decrease, right? So if I drink a lot one day, if I don't drink at all, the number of children I have does not change. So if you remember, we talked about covariation of cause and effect a long time ago. This is an example of that, right? There's no covariation, so that it can't be a causal relationship. There's no relationship between those two variables. Sometimes what can happen is what's called a curvilinear relationship. As something goes up, it goes up to a point, and then at a certain point, it goes down, right? So we'll use drinking again. I go to a party, and it doesn't seem a lot of fun, right? I don't know anybody. My friends were going to be there. They bailed, but I was like, oh, maybe I'll just go, right? And I'm just like not really feeling it. But random stranger comes up and like, you want to do a shot? And then, I decide to do a couple shots, and then I'm like having the time of my life, right? I'm dancing, I'm having great conversations, and then somebody's like, you want to do more alcohol, right? And so all this fun that I'm having, all of a sudden, oh, feel a little dizzy, oh, feel a little nauseous, uh-oh, I'm passed out in the bathroom in a pile of my own vomit. Not a puddle, a pile. So that would be a curvilinear relationship, right? As this thing increases, the dependent variable increases to a point, but then drops off, right? So the you can look at other things and you'd be able to find similar relationships, but it's either going to be negative, positive, zero, or curvilinear. So the last thing that you want to know about these correlations is that there's something called a correlation coefficient. A correlation coefficient is a easy way of understanding the strength of a relationship just by looking at a number, right? So the correlation coefficient that we're going to see for most of the semester, I'm just going to tell you right now, is R, and R can equal +1. You can have an R that equals 0. You can have an R that equals negative 0.8, right? These R ranges, these R scores range from -1 to +1, right? Now, if a number is close to 0, that's going to reflect a weak relationship. So this is no relationship. This is R equals 0, right? If it looks like this, and that's R equals +1. As this increases, we see this increase. It's a perfect relationship. Now we can also look in the opposite way. R equals -1. As this increases, this decreases, right? So that is a perfect negative relationship. Funnily enough, if you have a curvilinear relationship, it's R equals 0. The reason for that is because the correlation coefficient is what's called a linear regression line. So what it does is it takes that curve and then it finds the average of that, which looks like that. So according to the Pearson R, your graph looks like that even though it's curvilinear. We'll talk later about how to deal with that, but just know that just because you have an R that equals 0, it doesn't necessarily mean that there's no relationship. Sometimes it means that there's a curvilinear relationship. So here we can see different examples. So we have a strong positive correlation. So that's R equals 0.9. We have a weaker one, R equals 0.6. Then we have no correlation, R equals 0, right? Then we also have a strong negative correlation. So a lot of people see negative and they think bad, but negative doesn't mean bad. If it's close to 1 or -1 on either end of that spectrum, right? This is strong and this is strong. Now, if it's close to 0, right, everything within this range is pretty weak. So the closer it gets to the extremes, the stronger it is. So we have a -0.7, which is okay, but it's a little weak, right? And then we have -1, which is a really strong correlation. So we'll talk about scatter plots later, but what we're seeing, each of these is an individual score. And what the regression line does is it tells us, okay, on average, what is the data doing? And in this case, on average, it's going up, right? Over here, on average, it's going down. So correlation coefficients are a very easy way of kind of understanding what the data is doing. And really, it just tells us what the strength of that relationship is. So that's all for now. Take a break, digest it a little bit, come back to it. We'll talk about these concepts more and more. Just make sure you get a general understanding, right? So do you understand the difference between construct, internal and external validity? And then do you understand what a strong relationship would look like versus no relationship or a weak relationship or even a curvilinear relationship. Okay, that's it. Take care and drink some water. You probably forgot to drink water today, so drink some water.